And so question 10 then from the 2016 Advanced Higher Mathematics of Mechanics. 6-mark question, easier 6 marks than the previous 6. And question 9, much quicker question. A stone is thrown from the top of a cliff and the subsequent motion is modelled by these two parametric equations. And even without looking at the rest of the question, you can see what's happened. In the x direction, that's just vt, so the horizontal velocity is 4 meters per second. In the vertical direction, forgetting that part, there's the ut minus a half, well, ut plus a half at squared, but since gravity is going down, there's your ut minus a half of gt squared. So it must have been going upwards at 2, and that 20 simply means it's not starting at ground zero, it's starting 20 metres up. So there's your cliff. 20 metres up, 4 meters per second across, 2 meters per second up. Anyway, what does it say? Use parametric differentiation to find dy by dx in terms of t. So it doesn't actually matter what the rest of the question is for this first part, because it just says what's dy by dx. Problem is, of course, x is expressed as a function of t, and y is expressed as a function of t. So the first thing you can do then is only find dx by dt, which will be 4, and dy by dt, which, of course, that disappears being a constant, which is 2 minus 10t. Which, of course, is just the horizontal and the vertical velocity. Horizontal velocity is 4. Vertical velocity, there's your v equals u plus at business, with a, of course, being going downwards minus 10. But it wants dy by dx, so then you'd say this. Well, dy by dx would be found by doing dy by dt and multiplying that by dt by dx. So that would be dy by dt is 2 minus 10t. Multiplying that by the reciprocal then of this, which is 1 over 4, so that's over 4. So dy by dx is going to be whichever way you like. That's a half minus 5 upon 2t. So there was 1 mark for differentiating with respect to t, and there's another mark for shuggling your differentials to get dy by dx. B, part 1, for 2 marks. What's the angle of projection of the stone? Well, you know that straight away. You know this from the first part. Horizontal velocity 4 at the start, vertical velocity 2, which means that this angle of projection then, for that angle it's going to be 2 over 4. Inverse tan 2 upon 4, inverse tan a half. Anyway, but since they're leading you along this path, I presume they're going to say, what's the angle of projection? Well, of course, if that's the gradient, then the gradient's the same as the tangent of the angle. And at the start, t would have been 0, so you're working out what happens at t equals 0. At t equals 0, the gradient's going to be given by dy by dx, which is a half minus 5 upon 2 times 0, which is a half. And if the gradient's equal to that, that means the tangent of the angle is equal to a half, so theta will be inverse tan of a half. And that gives you 26.565 and so on degrees. So maybe I'll just finish it because I didn't mention a theta. Angle of projection equals 26.5 degrees. Oh no, it's 0.6. Or if you fancy, change it into radians. I would just leave it degrees. Yes, but right now it's 26.6, so I've got the right answer. And the 2 marks here were, first of all, by putting t equal to 0. So you get the angle at the start and getting the answer a half. And then the second marks for getting the actual angle. And the second part, just squeeze it in over here. And now it says by considering dy by dx, you haven't got any options of doing anything else. By considering dy by dx, in other words this formula here, find the value of t when the stone is moving at 45 degrees below the horizontal. Well, dy by dx would then equal, well, 45 degrees down is a gradient of -1. If you weren't sure of that, you could just have worked that out. M would have been the tangent of -45 degrees, which would come out as -1. That's worth a mark. So putting that into your formula, a half minus 5 upon 2t is -1, doubling it all. and then taking that 1 across, you'll have negative 5t would be, that gets doubled to negative 2, negative 3, so t is going to be 3/5 of a second. Or if you want a decimal, 0.6 seconds. And that's a mark.